This is practice quiz problem number 2. In this problem, block A slides down a frictionless chute and then hits block B, which is stationary. As shown by the LOL diagram on the right, block A begins with some gravitational potential energy, which is then converted to kinetic energy as the block slides down the chute. Part A asks us to find the velocity of block A at the bottom of the chute. To do this, we need to use the UG and K equations. In step 1, we use the UG equation. We plug in our known values, and we get UG is equal to 8 joules. In this situation, UG is equal to K because no work is being done on the system. In step 2, we use that 8 joules along with the kinetic energy equation to solve for the final velocity of block A, which is 2.828 meters per second. This velocity is before the two blocks collide. Part B asks us to find the velocity of block A and B after they collide. This is assuming that the two blocks stick together. So in step 3, we use the conservation of momentum to solve for the velocity. We know that the initial momentum is equal to the final momentum. And so we plug in our values and we get a velocity of 0.505 meters per second. Also note that VF2A refers to the velocity of block A after the collision, while VFA refers to the velocity before. Part C asks us to find the impulse on A during the collision, and Part D asks us to find the impulse on block B during the collision. Impulse is delta P, or change in momentum. The momentum is transferred from block A to B, so delta P for A should be equal to negative delta P for B. To solve for the change in momentum, we can do final momentum minus initial momentum. And we get the delta momentum, or the impulse, for block A is equal to negative 4.647 Newton seconds, or kilogram meters over seconds. While for block B, once we plug in the values, we should get positive 4.647 for the impulse. And again, the units are Newton seconds or kilogram meters over seconds.